start now my presentation about AI. But first, let's listen to some music. Let's listen how it plays. It's going to be a little bit cringy.
We couldn't meet halfway. We couldn't
Deconstructed slowcore.
You couldn't keep me safe.
Female
I couldn't
vocalist.
save you anymore. We couldn't take it back.
I will not read this.
Couldn't rewrite the past. You couldn't make me stay. I
Existential
couldn't make you
anti-melodies.
How did it come to this? You just can't forgive. This
Do you like it? Who is doing that? Who is singing? Who is the performer? Let's see. Maybe it's who? Billie Eilish? Maybe Taylor Swift? Maybe Beyonce? Maybe Suno AI? It is Suno AI, and they use ClickHouse as well for generative AI to generate, maybe for analysis of their generation. But anyway, they use ClickHouse for this interesting use case. And so when we have a model, we have a prompt, and it generates some responses based on a lot of data, based on a lot of numbers, a lot of weights, biases, and so on. It looks simple. And I will not tell you about how to train your models. Instead, I will tell you about the data behind these models. How to find the data, what kinds of data the models are made of. And there is a lot of data from the internet. For example, Common Crawl, which consisted of HTML pages, crawled once a month from the internet, from all the websites. It contains a lot of duplicates, a lot of inappropriate data, but anyway, it's a raw data set. There are many data sets that are based on Common Crawl after additional preparation, additional analysis, filtering, I would say, garbage data, deduplication, and so on. Data sets like ZPile, OpenWebText, or FineWeb2. There are data sets from social networks like Twitter, Stack Overflow. There are data sets that are pretty clean and small, like Wikipedia. But if you take just Wikipedia as a data set, your language model will be uninteresting, I can say even boring. If you want to make a less boring language model, take Reddit or even 4chan, and supposedly you will have a lot of fun with that. If you want multimodal data, there is YouTube, Flickr. I'm not sure if you can scrape YouTube, but at least you can try. And let's take a look at the sizes of this data set, how big they are. Common Crawl every month contains about 2.5 billion HTML pages. The total size of HTMLs is half a petabyte. But it is uncompressed. Compressed, it is just 100 of terabytes. And if we take only text and compress it, it will be just about 10 of terabytes per month. So pretty reasonable size. You definitely can load everything into ClickHouse. For comparison, Wikipedia is pretty small, just a few gigabytes of like well-filtered human knowledge. And other data sets have their own specifics. So what to do with these data sets? Can we analyze these data sets? When I see any interesting data set, the first thing I do is I'm loading this data set into ClickHouse. Because there can be could be two outcomes. Maybe the data set is too big and it will not load. Unlikely, but anyway, if I will find this case, I will find the reason, and I will optimize ClickHouse even more to accommodate this data, and I will be happy. If the data set will load successfully, I will also be happy. So I'm trying to do it every time. Find a data set, load it into ClickHouse, and be happy. And this is the way how I am so happy every day. And good news is that many of these open datasets are published and available for downloads on Hugging Face or on Kaggle, on other services. And Hugging Face provides an API. Let's use this API to take a dataset, in this case, FineWeb. Let's take a look at this query. It is a ClickHouse query from the URL table function. The URL table function will request Hugging Face API for the list of datasets, the list of files consisting the dataset. And this list will be provided as an array. Then I use array join function to flatten this array and to count its size. It is 26,000 of files and 46 terabytes of compressed data in Parquet files. Now let's take a look at these files. It is about 25 billion records, 73 terabytes of uncompressed text, and with metadata, uncompressed size is 81.5 terabytes. And we can easily list these files, list the URL, and what to do next. Let's start loading. The first thing we have to do is to create a table. And to create a table, I don't even have to specify the table structure. I will just do it like this. Create table, empty as select, star from URL. And it will automatically derive the structure. In this case, we have text, we have URL, string, we have the number of tokens, language. So let's use this table and do inserts. To do inserts, I will make another query. And this query will generate 26,000 more queries. It will generate 26,000 insert queries for loading every Parquet file into ClickHouse. And then I will just run everything in parallel in 50 threads, just piping these ClickHouse queries into ClickHouse client and loading inside ClickHouse cloud. I have two questions for you. First question, did Hugging Face ban me when I was loading in 50 threads all this data? What do you think? Did it let me load this data? Yes, no, yes. Actually, it did. Surprisingly, I downloaded all of this data from Hugging Face, all 46 terabytes successfully. The second question, how much did it take to insert all of this into ClickHouse? What do you think? 2 minutes? 50 minutes? 30 minutes? 5 minutes? Couple of hours? What database do you use at work? Do you use Oracle? Why do you say a couple of hours then? Any more hypotheses? 40 minutes? 4 minutes. And I think you definitely use ClickHouse at work. Okay, let's take a look at the actual result. Actually, it took 72 minutes. So 1 hour and 12 minutes to load 33 and 6 terabytes of compressed Parquet files inside ClickHouse cloud service. And what is interesting, it was 46 terabytes of Parquet files, but inside ClickHouse, it took only 33 terabytes. And it is interesting why. Because in ClickHouse, data is stored in columns, in column-oriented data format. And Parquet is also a column-oriented data format. There should be no difference. ClickHouse uses ZSTD compression, and Parquet file, I checked that, it also uses ZSTD, Z standard compression. So there should be no difference. But the fact is ClickHouse just does it better. It compresses data better. We have this more than 20% for free just due to the fact that the data is inside ClickHouse. Now let's take a look at this data and explore. So we have fine web data set with a lot of websites. Which websites are the most represented in this data set? So let me run this query. It runs quite quickly with a speed of 250 gigabytes per second. It processes 1.5 terabytes, 1.7 terabytes, okay. And the top websites are Wikipedia, The Guardian, Business Insider, Fox News, New York Times, Fan Fiction, Tampa Bay Daily Telegraph, TripAdvisor, Bloomberg, Daily Mail, New York Post, Variety. So mostly Wikipedia and news. If you take a Fine Web 2, you can actually train a pretty capable language model similarly to Llama version 2. Not like the state-of-the-art language model, but probably these models are also made from this type of data, Wikipedia and news. Now let's take a look at other data sets, because Fine Web is not enough. We have GitHub. If you take GitHub and download all the repositories with like thousands of forks of Linux kernel and hundreds of forks of ClickHouse, maybe thousands, it will take 300 terabytes of compressed data. The question is, how do I know? How do I know that GitHub code takes 300, what? Exactly, because I downloaded that, I cloned all these repositories and loaded them into ClickHouse. There are other interesting data sets like archive with scientific papers. And you probably train your small language model on archive, but then this language model will speak in a passive voice, or passive voice will be spoken. There is Twitter, but I cannot download all the tweets, because if I do, probably Elon Musk will be angry on me. But there is a data set with about 1% of data from Twitter. Scrape it on the internet. That could be used for, at least for some research, statistical analysis. And the point is, all of these data sets will fit into just a single service in ClickHouse Cloud, because everything will fit into a single service in ClickHouse Cloud. ClickHouse Cloud is almost infinitely scalable. Let's use it. And let's compare these data sets by their characters, but by their distributions of data. And the first thing I want to do is very simple, like the most simple thing that is possible. I will just count words, tokens. Let's take a look how to do it. First, I'm creating a table with token statistics for each data set, like token statistics for Blue Sky social network. And I will use this insert query. This query does select it takes the text, normalizes this text, extracts words into an array. There is a function named tokens. Then I am flattening this array, and I will be inserting number 1 into that table. But the table has a special engine, summing merge tree. So this table will sum this data while inserting and during background merges. And I will get all the statistics. And in addition to that, I also calculate statistics of bgrams. I can do 3 grams, 4 grams as well. And for this purpose, we have another function in ClickHouse, array shingles. It takes an array, and it takes pairs of consecutive elements from the array. So you will get these bgrams. And again, I insert all of them into this tokens statistics table. Then I'm comparing the style of different data sets. Let's suppose we have Hacker News and Blue Sky. And let's take popular tokens and find out which tokens are more represented on Blue Sky than on Hacker News, and vice versa. Let me copy-paste this query and run it. It is quite fast. Yeah, so top tokens on Blue Sky. Social, her, she, him, love, please, hope, today, so much, yeah, fun. On Hacker News it is data, Google system, problem, that's it. I find Blue Sky way more fun. And Hacker News containing way more problems and systems. I did this exercise for other data sets. And for example, on Reddit, the top tokens are action, level, pretty, content, and yourself. And I will not say which goes before yourself. Also, Wikipedia is pretty interesting. The top tokens are not interesting, but the least represented token is you. Because for some reason, you are very unpopular on Wikipedia. And me as well, I don't have a Wikipedia page. Let's do something even more interesting. So remember that FineWeb dataset. And it contains many, many websites, including Blue Sky, including Hacker News and Reddit, just a bit from Reddit and Wikipedia, and also something from ClickHouse.com. I checked, and it has pages from ClickHouse.com. What I will do, I will create fingerprints for the style of every website. And to do that, I will do this simple SQL query in ClickHouse. Let me explain this. Let's define the vector size, 1024 in this example. Now let's take every word, every token from the dataset and calculate a hash, cityhash64. And take the remainder of division of this hash to the vector size. And it will give a position inside vector. And for every token, I will take the position and increment the integer value by 1. I'm doing this with this higher order function array map, and then some arrays with aggregate function, sum for each. It will sum arrays horizontally. So I have multi-dimensional arrays for each record, and I will do summation for each dimension, which is sum for each. Okay, probably it's not so simple, but it's just a few lines of SQL. Now let's try and find which websites are the most similar to clickhouse.com. Let me copy-paste the query and see the result. The first one is clickhouse.com. Okay, then imply, red panda, planet scale, source graph, confluent, dgraph, and airbyte. Apparently, my method works. And it was so simple, it is not even AI. It is just data mining, data science, classical data science. And it works quite well. Now let's take a look at another query that will give me trends in the internet. So distribution of tokens over time. Let me copy paste another query and see the trend of love on Reddit. Here is love on Reddit. What about ClickHouse? ClickHouse is growing. What about Hadoop? Hadoop is not growing. What about blockchain? Blockchain is still strong, but it is quite volatile. Okay, now interesting. If I take 1 billion of photos from Flickr with all the metadata, what to do with 1 billion of photos? I would like to do something equally interesting or even more interesting from this data set. What would you suggest me to do? Generate a report by sizes of photos. That's easy. Yeah, but what? Find a person like me. I don't think they exist. Analyze metadata. Most popular camera. Yeah, interesting, but actually I did something a little bit different. What? Color. Places. That's close. Let me show. I generated a map of these photos, and this is just the density in Europe. But I can also press on this button, and then it will generate hundreds of queries in ClickHouse and find the top-rated photo for each location. So in real time, it does these hundreds of queries, and I can do this selection tool and generate a report. So like top photos in Italy, top distributions by tags. And this website is published. It is publicly available. You can find it on the internet. And there are many more interesting data sets with not just 1 billion of records, but hundreds of billions of records. A few takeaways. Whatever data set you have, ClickHouse makes it easy. ClickHouse makes it fun working with that data set. And supposedly you can take all the internet and upload it into ClickHouse. And then the internet will probably work faster. That's not all. So let's continue about AI and machine learning. So ClickHouse has proven itself as a foundational component for many AI companies, for many processes behind AI, as a backend for agents. It can work as a vector store to do vector search, as has been shown in previous sessions. But what else? One example, in version 25.8, we made generally available production-ready implementation of our vector search index. It uses HNSW algorithm. It provides approximate search. You can specify different types of quantizations like 16-bit, bfloat 16, which is by default, 8-bit quantization, or even binary quantization. It supports pre-filtering and post-filtering and rescoring data, so selection of candidates, and then rearranging these candidates over the actual distance. And let's also take a look about the model of usage of ClickHouse, how accessible ClickHouse is. So first let me show you how would you query ClickHouse like 50 years ago. If you were 50 years ago, you have a nice database. You did not have ClickHouse, but let's suppose. And you are a database engineer, database developer, then you will just use ClickHouse client. It is a nice tool. I really like it. I use it every day. Many of you also use ClickHouse every day. And if you want to make reports on top of your data, like on top of property prices in the UK, home prices, you will just write SQL queries, and here is the result. It's pretty easy. Nice, and I like it. Now, this is a classical example of real-time analytics. Users do a few queries, or users use an application. Application is able to generate reports by doing a few queries into ClickHouse. What is changing with AI? With AI, you can use your agents. And agents will take an input, just a question in the natural language. They can use ClickHouse MCP server, explore the database schema, explore the list of tables, read the descriptions, column names, comments, generate SQL queries, run these SQL queries, run more SQL queries. And the point is, when we have agentic analytics, so agentic analytics is like a combination of real-time analytics and agents that do these queries. The difference is that now the number of queries increases significantly. You just make one question, and the agent will do tens, maybe even 100 queries to real-time database. And you are happy if your real-time database is ClickHouse. Because in ClickHouse, every query will take 100 milliseconds, maybe 1 second. In other databases, who said that he used Oracle? Probably every query will take, I don't know, minutes, and you will get hours just to answer your question on a natural language. And when I ask questions, I don't want to wait. I don't want to be distracted. So the database must be fast. And ClickHouse is exactly this kind of database, with high performance querying, with low latency data, with a lot of external data sources, support for external data sources, integrations. So I can confidently say that ClickHouse is the best database for agentic analytics. And this is proven by the usage of our tool Dwayne, for example, that we use for data warehouse. Just in April this year, our internal users generated like 15 million tokens. And more importantly, that today, not just analysts, but me or my colleague, my co-founder Aaron Katz, all these people often don't ask to create dashboards. They just do queries on natural language. They still have to have a little bit of intuition to recognize the quality of generation. But the result is here. Most of the usage of our internal data warehouse is currently done by Dwayne, the AI agent. Let's take a look at the adoption of databases, how to make databases accessible. So, like a few years ago, databases were accessible for database DBAs, database engineers, but it is not enough. What about the introduction of model context protocol? And actually, it changes a lot. So with the model context protocol, you can implement your applications on top of ClickHouse on a local machine or using a remote model context protocol in ClickHouse Cloud, which is available by a single click. You see the list of interfaces like HTTP, TCP, native, MySQL interface, and with a single click, you also enable MCP server. You get an endpoint, and what you can build something not for database developers, but for other kind of developers. Let's take a look. So let's enable this MCP server in ClickHouse Cloud. Let's enable this checkbox. Here is the endpoint. Let's use this endpoint from our favorite development environment. And here I generated a Node.js application on top of property prices in the UK. But more importantly, I don't have to make it an application. I can just query my data using natural language from any kind of tool, just from Cloud Desktop or from my development environment or from LibreChat. So it looks like this. I have a query: what are the most interesting investment opportunities in the UK house market? And here it is, a house with 500 million pounds. Probably it's, I don't have that kind of money to do this kind of investments. But anyway, the suggestion was great. I appreciated that. Let's change my application to apply and to use to enable another report about like the most expensive places. City of London is obviously the most expensive. So this is how it works, and the result is that now not only database people, not only developers, but literally everyone else are able to use these massive databases to do quick real-time analytics on massive databases. And this is all the point of this AI integration MCP protocol. So if you want to learn more, ClickHouse AI contains blueprints how to build your AI applications. It contains examples, customer stories, a recommendation how to use ClickHouse for AI.